In this video, we are going to be going over additional examples for section 13.3. So looking at problem 1 here, let 10, negative 10 be a point on the terminal side of angle theta in standard position. Evaluate the trigonometric function of theta, and then find the sine of theta. So the very first thing that I would do is I would always go to a graph and I would graph. So 10, negative 10 is going to be, right here. Right? I know it's not exact, but I know that this distance is going to be 10, and then I went negative 10. So this distance right here is going to be negative 10. And then I draw my triangle. It is always helpful to draw on that triangle. So I have both of these legs, and then very first thing I need to do is find my hypotenuse. So in order to find my hypotenuse, I'm going to use the Pythagorean theorem. 10 squared plus negative 10 squared equals c squared. 100 plus 100 equals c squared. 200 equals c squared. And then when I take the square root, c equals the square root of 200. Breaking that down exactly, c is going to be 10 radical 2. Or you could have recognized that the lengths of each of the sides were both 10. The actual lengths were both 10, so it is going to end up being a 45, 90 right triangle. Alright, so it holds the same special relationships. So you have your leg times radical 2. Alright, so if I were, this is theta. Theta is always at the origin. So if I were to find the sine of theta equals the opposite over my hypotenuse. And the opposite side in this case is negative 10 over my hypotenuse, which is 10 radical 2. And reducing this, I get negative 1 over radical 2, and then I need to rationalize my denominator, radical 2 over radical 2, and I get the sine of theta. Sine of theta is equal to negative radical 2 over 2, which that's an ugly looking 2. Alright, so over here I would they actually don't go through the full rationalizing process, so I need to look back at a couple of steps here, and the answer should be B. Alright, problem number 2. Let 9, 9 be a point on the terminal side, so I'm doing something very similar. So I have 9. Alright, let's go ahead and say that, right here is 9. And this is negative 9, so that's negative 9. This is positive 9. When I have my angle here, my angle theta, alright, when I find my hypotenuse, I'll do 9 squared plus negative 9 squared, and if you do the math behind that, that is 9 radical 2. So when I complete what they ask of me this time, the cosine of theta is going to be positive 9 over 9 radical 2, or that's 1 over radical 2, and if you were to properly go through the rationalizing of the denominator, it would be radical 2 over 2. However, here they don't rationalize the denominator, so your answer is A, 1 over radical 2. In problem 3, it's going to be the same process, however they're asking for the secant. Alright, so I've got 8, negative 8. Alright, so this side of my triangle is 8, this side's negative 8, got that right angle here, here's theta. And here they're looking for the secant, so you go through the process of finding your hypotenuse using the Pythagorean theorem again, and you should get 8 radical 2, and they want the secant. So I never, ever, ever remember secant. I don't have that memorized, but I do know that it is related to cosine. So I know the cosine of theta is adjacent over my hypotenuse. So I know that the secant must be the hypotenuse over adjacent. I never remember that outright explicitly. However, I can always construct it using cosine. So my hypotenuse is 8 radical 2 over my adjacent side. So this is the adjacent over 8, and that's going to reduce to radical 2. Alright, so here my answer should be C. Problem number 4. Let negative 415 be a point on the terminal side. So here we are changing which quadrant we are in. Alright, so negative 4, we'll go ahead and say that this is negative 4. Then we go up 15. Alright, so the height here is 15. And then I draw my angle to the origin here. And whichever, way theta is going, this becomes theta prime. That is called my reference angle, and here is theta. First step again, I need to use my Pythagorean theorem and do negative 4 squared plus 15 squared equals c squared. Now, if you looked in the book, you should have seen the shortcut of r equals the square root of x squared plus y squared. So we are doing the same thing here by using the Pythagorean theorem every time, but you can straightforward square each of the x and y, add them together, and then take the square root after that. So you should get 16 plus 225, and so c squared equals 241, c equals 241 to the 1/2 power, or the square root of 241. That does not reduce in radical form at all. It does not simplify. So it just is the square root of 241. So I'm going to write that in on my triangle, 241. And they ask us for the sine of theta. The sine of theta is going to be the same as the opposite of the sine. It's actually going to be the exact same as the sine of theta prime. By that I mean we have this abbreviation we talked about. All students take calculus. That means in quadrant 2 here, the sign is going to be positive. So the sine of theta is the same as the sine of theta prime. So I can go ahead and find the opposite over the hypotenuse here. And the opposite is 15 over square root of 241. For an actual problem, you would want to rationalize the denominator, but in this case, they give us an option a different way. Alright, so my solution should be D. Alright, problem number 5. I have 8, negative 8. That is going to be in my fourth quadrant here. So 8, and then I've got negative 8 on this side. Alright, so the side length is 8, but it is negative. Alright, so negative 8. And then here is theta. Alright, going through the Pythagorean theorem here. Just erase my beautiful triangle. Going through the Pythagorean theorem, you would find that the hypotenuse is 8 radical 2. Or using r equals the square root of x squared plus y squared. That becomes x squared is 64. Y squared is a positive 64. That becomes square root of 128. And if you break that apart, just like you put it together, it's the square root of 64 times the square root of 2, or 8 radical 2. Alright, so I need to find the cosine of angle theta. Cosine of angle theta is going to be my adjacent, 8, divided by my hypotenuse, 8 radical 2, which reduces to 1 over radical 2, and properly going through the rationalization of the denominator, you would multiply by radical 2 over radical 2, and you would get radical 2 over 2, but not in this case. And you do need to keep in mind all students take calculus. So here, the sine of theta, or the cosine of theta, is going to remain positive, alright, which that makes sense. So it's 1 over radical 2, which would be A. In problem 6 here, I've got -2, 7, -2, up 7, just about. Keep in mind, this is a horrible drawing. Alright, and here's theta, here's my right angle. I'm redrawing this for you guys. Alright, this is theta, and this reference angle would be theta prime. And I'll draw in my right angle there. Alright, using my Pythagorean theorem or my square root of x squared plus y squared, I would get my hypotenuse to be square root of 53, and since 53 is prime, it's not going to reduce at all. And here in this problem, they are asking me for the cosine of theta, keeping in mind that all students take calculus. This is going to be negative. So, negative cosine of theta prime. So then I just set up the cosine of theta prime like normal with a nice cute little negative sign out here in front. So the opposite of -2 over the square root of 53 gives me a +2 over the square root of 53. And in real life, not in this crazy little notebook, I would rationalize my denominator and get 2 radical 53 over 53. Alright, but in this case, we're going to use the 2 over radical. And as you see, that is none of the options, which means I did something wrong in my logical thinking here. So when I set up this triangle, I put -2 there, which means I put a -2 here. Now actually setting up my triangle, that should be a +2 because I should be talking about distance. So I need to rethink everything that I've been doing. So it should actually be a negative. Since my cosine, I know that the value should come out negative since it's in the second quadrant. Alright, so I just need to be careful with setting up my triangles from now on. So the solution here should be D. Alright, problem number 7. Find a reference angle for 23 pi over 12. So without fail, what I always do is I draw this little coordinate plane really quick. This is 0, this is pi, coming back around, this is going to be 2 pi. I know that halfway between pi is pi over 2, or 1/2 pi. And then between 1 and 2 pi is 1/2 pi, or 3 over 2 pi. And I kind of use these values to figure out which quadrant these reference angles are going to fall into. So 23 over 12, I think about that as 24 over 12, so it is almost 2 pi. So I know that it should fall into this fourth quadrant somewhere. So since it falls into the fourth quadrant, what I want to do is I want to take that 2 pi I want to take that 2 pi and subtract. So I'm going to be taking 2 pi, and then I'm going to subtract 23/12 pi. So that's actually converting it with a common denominator, 24/12 pi minus 23/12 pi. And my reference angle should be 1/12 pi, or that's the same as pi over 12. So that's going to be my reference angle. So I need an additional pi over 12 to get me back to the x-axis, back to that 2 pi there. Alright, looking at problem number 8, a reference angle for 93 pi over 47. So 93 pi over 47, setting up this up, pi over 2, pi, 2 pi, and 3 halves pi. Alright, so looking at 93 over 47, if I do a quick check here, what is 47 times 2? 47 times 2 is 94, so it is almost, yet again, almost 2 pi here. Alright, it's going to be pretty close. I'm kind of looking at the relationship between that 93 and that 47. It is almost double. So what I need to do is I need to take that 2 pi and subtract 2 pi, and then I'm going to be subtracting 93 pi over 47, finding a common denominator. That becomes 94 over 47 pi minus 93/47 pi. So my reference angle here is going to be 1/47 pi, or pi over 47. Alright, and I'm going to be skipping problem number 9, since it goes over the exact same thing. So all of those angles fall into the 4th quadrant. It would be a little bit different if my angle, so here is my angle, if it falls into the 3rd quadrant, what I want to do, I always draw it out just so I can see. I go past 180, so I'm going to be taking theta minus 180. If my angle were to fall into the 2nd quadrant here, 2nd quadrant, I would take instead 180 minus theta, my angle. And if it were in the 1st quadrant, that means it is an acute angle, and I would just use theta itself, or I could keep subtracting 360 to find a coterminal angle that falls in that 1st quadrant. Alright, so looking at problem 10, what is the reference angle for negative 162 degrees? So I am going negative, so negative 90 goes to here, and then not a full negative 180, so here is negative 162. Negative 162 degrees. So my question needs to be, how far away from the x-axis, or that negative 180 degrees, are you? So what I need to do is look at a positive coterminal angle. So the positive coterminal angle to negative 162, so I add 360, and I get 198. Alright, so if this were my angle instead, 198 degrees, what I would need to do is take theta minus 180, so 198 minus 180 equals 18. Alright, so my answer here is 18 degrees. What is the reference angle for negative 160? That's going to be very similar, still falls in that 3rd quadrant there, and instead it is going to be 20 degrees. Alright, negative 389. This sounds like more of a challenge. So negative 389 degrees. So, here is my starting point, and I just went negative 360. Congratulations. Alright, and then I need to go past 360 by 29 degrees. So here is 29, an additional negative 320, or a negative 29, which is a grand total of negative 389. So here is my terminal side. It is in my fourth quadrant. And exactly how I drew that out actually helps me. So my reference angle here is that 29 degrees. Alright, and you can always get that by finding your positive coterminal angle. So a positive coterminal angle that would go with that would be drawn like this. And if you remember, negative 389, and then you add that 360, that gives you negative 29. Keep adding an additional 360, and that gives you 331. Alright, so my positive coterminal angle is 331. So what I need to do is take 360 minus theta. So 360 minus 331, and that gives you that 29. Alright, that's the way the book's going to do it. So problem 13 here. Finding the reference angle for 140 degrees. Drawing it out. Positive 140 degrees. I go past 90, and then I'm not quite to 180. So this is 140 degrees, and I need to be thinking about, well, how far away from 180 is it? So I take 180 minus that 140 minus theta, and that gives me 40 degrees. B. Alright, and last two problems here. Problem 14, the Frogbot is a robot designed for exploring rough terrain on other planets. It can jump at a 45-degree angle with an initial speed of 15 feet per second on Earth. The horizontal distance, d, in feet, traveled by a projectile launched at angle theta with an initial velocity, or speed, in feet per second is given by this following formula. D equals v squared over 32 times the sine of 2 theta. How far can the Frogbot jump on Earth? Alright, so they give you a formula. Since they give you a formula, especially if this is the ACT, here's what you do. You box it, and then you just try to fill in the variables with what they're saying. So they said 45-degree angle. Well, what variable does the angle go in for? That would be theta. Alright, so this is the sine of 2 times 45. And it says initial speed, or velocity, of 15 feet per second. So this is 15 squared over 32. So working it out step by step, that is 225 over 32 times the sine of 90. Okay, now I'm not going to need to use my calculator because I know my quadrantal angles. This is a quadrantal angle. By that I mean it falls exactly on an axis. Here is 90 degrees. And if I were to use my unit circle, that means the radius is 1. This point is 0, 1. And if you remember, cosine is my x value, and the sine would be my y value for these quadrantal angles. So the sine of 90 is 1. Alright, since the sine of 90 is 1, this equals 225 over 32. I don't know how that became a 33. Alright, over 32. And that is it. That is exact. Now, if you were to approximate it, it would be just over 7 feet. Alright, and it does say round to 2 decimal places, so when you type it in, it's going to be 7.03. And looking at problem 15 here, estimate the horizontal distance traveled by a track and field long jumper who jumps at a 26-degree angle and 15 feet per second. So using the exact same formula, setting it up, sine of 2 theta. Alright, 26 goes in for theta, and 16 goes in for velocity. So 16 squared over 32 times the sine of 2 times 26, sine of 52. Now here I can't use any of my quadrantal angle knowledge or anything that I have memorized for a 30, 45, or 60-degree angle. I need to use my calculator. So this is 256 divided by 32, which comes out evenly. 8 times the sine of 52. Alright, and since this is in degrees, you need to make sure that your calculator is in degree mode. Alright, so if I go to my little calculator app, I need to make sure that on whatever calculator I have, I press mode, and then I need to arrow down, make sure it is on degree, then I clear that out, and it was 8 times the sine of 52. Press enter, and I get 6.30. About 6.30, and it did say round to the nearest foot, so I would type in 6 feet. Alright, as always, if you guys have any questions, feel free to ask.